Aloha. In the evolution of data analysis, there has been a noticeable shift in how we categorize data analytical practices. In this presentation, we will explore how we can reconceptualize the taxonomy. Traditionally, statistics has been divided into two major branches: descriptive statistics and inferential statistics. Descriptive statistics involve summarizing and presenting data in a meaningful way, such as means, medians, standard deviations, and visualizations like histograms and bar charts. Inferential statistics, on the other hand, involves drawing conclusions from a sample to make generalizations about a larger population, typically through hypothesis testing or confidence intervals. However, definitions in this classical taxonomy often suffer from tautology. Some sources define descriptive statistics as the branch of statistics that describes the characteristics of the sample data, and inferential statistics as the branch that infers from the sample statistics to the population parameter. But saying descriptive statistics describes and inferential statistics infers is like saying a computer science professor is someone who teaches computer science. It tells you nothing new. Definitions should clarify rather than recycling the same language they aim to explain. In the world of data science and machine learning, DSML, a more modern and nuanced classification has taken root: descriptive, diagnostic, predictive, and prescriptive analytics. The first still refers to summarizing what happened, but the emphasis shifts to data visualization and pattern seeking. Diagnostic analytics asks why it happened, using tools like correlation analysis and causal modeling. Predictive analytics looks forward, using models to forecast what is likely to happen next. Common methods include classification trees, random forests, neural networks, and time series models. Prescriptive analytics takes it one step further by recommending actions based on those predictions, often through optimization algorithms or decision rules. This new taxonomy may be more complex, but it aligns better with business needs, strategic planning, and decision-making pipelines. Usually, the conclusion should result in actionable items. In that sense, the classical breakdown remains elegant and foundational, but the modern classification provides more practical utility in today's data-rich environments. There is a tantalizing question: are diagnostic, predictive, and prescriptive analytics just inferential statistics? Not quite. While there is overlap, they are not equivalent. Inferential statistics, in the traditional sense, is focused on using probabilistic methods to make statements about a population based on a sample. It's often theory-driven, with a strong emphasis on parametric assumptions and significance testing. The newer analytics types, including diagnostic, predictive, and prescriptive, are more data-driven rather than hypothesis-driven and goal-directed instead of method-directed. For example, a generalized regression model or a decision tree model can be used for inference and explanation, which is understanding the effect of variables, and it can also be used for prediction, which is forecasting probabilities, or even as part of a decision system, which is prescription. Thus, while inferential tools appear under the hood, the intended use of the analysis is what differentiates these new categories. The next important question is, does the new classification lead to practical applications? Absolutely. One of the core strengths of the new taxonomy is that it's not just about methodology, it's about purpose and actionability. In practice, this structure helps teams clarify the goals of a data project. Are we just reporting on trends? That's descriptive. Are we trying to understand underlying causes? That's diagnostic. Are we forecasting future sales? That's predictive. Are we deciding how much inventory to stock based on that forecast? That's prescriptive. This clarity helps analysts and decision makers align the right tools, teams, and expectations with the problem they're trying to solve. However, it's worth noting that the lines between these categories are often fuzzy. The same technique can serve different purposes depending on how it's applied. This makes context, rather than the method itself, the best guide for classification. The shift from classical to modern taxonomies in data analytics reflects a broader change in how we engage with data. While descriptive and inferential statistics offer a solid theoretical foundation, the newer model of descriptive, diagnostic, predictive, and prescriptive analytics offers a more flexible, goal-driven framework tailored for real-world applications. But clarity still matters. Definitions should illuminate, not echo themselves, and as the field evolves, so should our language and understanding. What do you think? Do you find the new classification more useful in your work or studies? Drop a comment or question. I would love to hear your take. If you found this video informative, please share and like. Thank you for watching.